Hi, my name is Guy Fredrickson. Today is December 1st, 2020. This is my new to me 1959 Chris Craft engine that was salvaged out of a 17-foot Sportsman. The person that owns that boat is turning it into a bar for his new house, and he posted this engine on eBay, and I bought it recently for $600. The core of this engine is a Chevy small block 283, and it's everything bolted to the outside of it that turns it into a marine engine. So the engine is cooled with lake water. So here's the raw water pump connected to the back side of the generator, which engages through a pulley with the flywheel, and we'll get to that in a moment. So this would have been connected to a seacock on the hull of the boat, the bottom of the boat. The lake water would come in to the pump. There's two compartments, two impellers, and it flowed from the pump to the engine through these two lines. One for the port side, one for the starboard side. The way these water-cooled exhaust manifolds work, so the water from the pump comes in here into a distribution plate. And this casting has 4 channels in it. 3 for the water cooling, 1 for the exhaust gases. So the water would flow up one channel to this end, loop around, come back to the back of the boat. From here, it would enter the engine block. So it would cool the engine block and the heads. And it would come out of the front of the head, back into the exhaust manifold for one more pass down, and then mix in with the exhaust gases here, and then go out the back of the boat. This is the flywheel end of the engine. So in an automobile, this would be the back of the engine, but in the boat, this is the front of the engine. So they call these flywheel forward configurations. This is an aluminum housing bolted to the engine block, and it provides the engine mounts on the starboard side and port side that would lay on top of the stringers. This is the starter, buried back in here in the starter solenoid. Probably just a standard automotive starter adapted for this use. This is the transmission. It's a Paragon. I don't know the model number of it yet, but it's just a forward, neutral, reverse gear. There's no reduction ratio. Your propeller shaft would connect here, and the axis of this shaft is directly in line with the crankshaft of the engine. The transmission is bolted to this casting, which makes the transition from the transmission to the engine block. This particular casting is aluminum, and I was told that Chris Craft recalled these back in the day and replaced them with cast iron castings because they had a lot of corrosion issues with the cooling water going through this aluminum casting. So I don't know the condition of that yet. All the nuts have been removed from these studs around the transmission, but it doesn't look like the transmission has been pulled off yet. Probably stuck on there pretty good, but it should slide straight back and disengage from the spline that's connected to the back side of the crankshaft. And here's the rear engine mounts, port side, starboard side. And you can see how the previous owner just ripped these off the stringers. carburetor looks in very rough shape. I don't know if it can be salvaged. Doesn't look like it. Here's a water pot fuel filter. It's kind of old school with the glass jar on it. And this was fitted with an electric fuel pump. So I don't know if this was original or not. A mechanical fuel pump would be connected underneath here, and it's just covered with a plate at this point. The oil pan is a bit larger on the marine engine than you would find in an automobile engine. There is a drain plug on the starboard side, buried underneath here, but you would never use that in a boat. There's just no place for the oil to go. There's never enough room underneath here to get an oil pan, and you would never just drain the oil into the bilge. So instead, what's done is you have your dipstick on this side, and inside the oil pan there's actually a tube that goes down towards the bottom of the oil pan. So you can remove the dipstick and then use a vacuum line and suck the oil out of the engine through that dip tube. Here's the distributor. So it's engaged with the camshaft through this aluminum housing. So the distributor goes down, and there's a gear at the end of the distributor shaft, and then your camshaft has a gear bolted onto the end of it, which extends out a couple inches and engages with the distributor shaft to maintain timing of the engine. So here's your coil, here's your ignition resistor. So in the Chevy engines in an automobile, this is where your distributor would be located, but instead we have this mechanism that engages with the camshaft and provides the connection of a rotary cable that goes from here to your tachometer on your instrument panel. Here's the oil pressure sensor. So the water temperature sensor is here in the intake manifold. There only appears to be one. On the engine that I'm familiar with, I had two water temperature sensors. One located here and the other here. One was connected to a gauge and one was connected to an idiot light on the instrument panel. That doesn't seem to be the case on this engine. Okay, I can't think of anything else right now to point out. As I tear into this, I'll make some more videos and let you know what I find. But I'm hoping to be able to use this engine block and heads and intake manifold on my boat project, which is a 1961 17-foot ski boat. So if this engine is worth salvaging, I'll have the block and the heads rebuilt. My original engine is almost identical to this one. It was also a 283, but it was too badly corroded on the water cooling side to salvage the block. So all the hardware on it was pretty much fine, but the block and the heads were shot. That's why I bought this engine. So I'll let you know how it turns out, and I'll post some more videos. Goodbye for now.